textbook, what is the mass of 6.99 times 10 to the 19th uranium hexafluoride molecules? In this problem, we're given the number of molecules of this particular compound. We're asked to calculate the mass. In order to go from molecules to mass of a compound, we have to convert first to moles. Recall in class, we set up a little flow chart here between these three entities. Our center box in class had moles of whatever we're talking about. It could be a compound, it could be an element, it could be an ion. Once we know the number of moles, we can convert in either direction to its mass. And mass, of course, will be in grams. In order to do that, our conversion factor is the molar mass. Units on that, grams per mole. In the other direction, if we know how many moles we have, or going in the opposite direction, we can calculate how many particles. So we've got the number of particles. And particles can be either a molecule, an atom, an ion, whatever. Avogadro's number is used for that. And here we have number of particles, now just abbreviated PART, per mole. So both of these are on a per mole basis, which makes it nice because we can use the mole as an intermediate going between mass and particles or vice versa. And in this problem, that's exactly what we're asked to do. We're given the number of particles, so let's put a check mark there. We're asked to calculate the mass of this number of molecules. Put a question mark there by mass. So we do this in our usual way. We're going to start with the measurement given, which of course is the 6.99 times 10 to the 19th uranium hexafluoride molecules. We're going to need two conversions because we've got to first convert to moles and convert moles to mass. So let's do it. Our starting point, 6.99 times 10 to the 19th molecules. I may run out of room, so we'll just erase as we need to. Equal sign, we want our answer in grams. The molecule, of course, is UF6. This is over 1. My first conversion factor then is going to be Avogadro's number. I need to convert number of molecules to moles. I use Avogadro's number. That number will be given to you on any quiz or exam. I want moles upstairs, so I'm going to have 1 mole divided by 6.022 times 10 to the 23rd. And in this case, the particle is molecules, so let's write that. Okay. And molecules cancel. So at this point, we have moles. That is to say, if we turn on our calculator and we divide the number of molecules by Avogadro's number, the answer we get on our calculator will, in fact, be the number of moles in this many molecules. But we're interested in grams, so we need our next conversion factor, which is the molar mass. So we're going to go to the periodic table and get some atomic weights or molar masses of the elements. UF6 is the compound of interest. So we have two elements. We have uranium, we have fluorine. Again, we're going to assume that we have 1 mole of UF6. We're going to calculate how many grams are in 1 mole, that is, its molar mass. There is 1 mole of uranium atoms in 1 mole of UF6, so let's start by writing out 1 mole. Now let's get the molar mass of uranium, and we see that uranium is on the lower part of the periodic table, an element we don't use too much, and that is 238.0 is the molar mass of uranium. That's the number we want. So let's put down 238.0 grams per mole. Moles cancel. I'm left with grams, which of course is going to be 238.0 grams. Now we do the same thing for fluorine. Of course, we see that there are 6 moles of fluorine in 1 mole of UF6, so we have 6 moles. And now we need the molar mass of fluorine. And fluorine is, let's use the sidebar here to get it on the chart. Here's our fluorine, element number 919.00 is our molar mass, so 19.00 grams per mole. And multiplying that out, we get 114.0 grams. 4 significant figures in both of our mass numbers here. So now we're just going to add these two together, and we add them up, we get 352.0 grams per mole molar mass of UF6. So that's our conversion factor now. So let's go back up here. Now we're going to erase this because I need more room. And my second conversion factor and last conversion factor is my molar mass. I want moles downstairs. I want grams upstairs. So I write 352.0 grams in 1 mole of UF6. Moles cancel. And now we have our setup complete. Grams upstairs is the only unit. Up to the left of the equal sign. So now I'm going to scroll down here to write our answer. And if you do the math, turn on your calculator, you should get a value of 0.04087 grams of UF6 in the number of molecules given. So this is our answer. We do have 4 significant figures. I'm sorry, we don't. We have 3 significant figures. I apologize. Our starting measurement had 3 significant figures. So we need to round this. So our correct answer is going to be 0.0409 grams of UF6. So let's highlight that in yellow. This is my correct answer with the correct number of significant figures.